let's run over method of calculating dosages of drugs as we have here. Methods of calculating dosages of drugs. Maybe I'll have some of us come and do it. So if you have your Mustafa with you, you can open it. So the first one is A. We have a Young's rule. Young's rule. What does it say? We have what, the age of child in years over age of child plus 12 times adult dose over 1. So this is the first one we did, the Young's rule. So we can only use this calculation for, we can calculate the dose of a child that is below 12 years old, right? Now, for example, we have how many milligrams of aspirin? So we ask the question, how many milligrams of aspirin, yes, will you give to a child that is 6 years of age, child is 6 years, when the adult dose is 600 milligrams. So using this formula, what do we have? We have age of child is 6 years over 6 years plus 12 plus 12 times what? 600 milligrams over 1. So since we have that over, what we now have is what we have 6 over 6 plus 12 times 600 milligrams, right? From here we have 6 over 18 times 600 milligrams. 6 here 1, 6 here 3, right? 3 here 2. So the child should take what, 200 milligrams of aspirin. So when you see any calculation like this, you should know whether you should know straight away whether you can use this formula. If they ask you to calculate the pediatric dose, they must give you the adult dose. The child must be more than 1 year old. The child must be more than 1 year old. Then you can use this formula. That is when you can use Young's rule. Having said that, we look at the second one, the B here, the fried man. The fried man's rule. What do we have with this? So the formula is what? The formula here is adult dose. Okay. Times what? Times age of child in months over 150. So once we have this, we know that looking at the formula, you must know the adult dose. They must give you the child's age in months. This one is a constant. What we are looking for is what? Pediatric dose. Do you get it? So what we are actually looking for is what? Pediatric dose is what we are looking for with this formula. I think that is clear. So the same thing we look for here. So this formula is just to get what? The pediatric dose. The pediatric dose. The same thing we're looking for this dose. So they must give us the question. Yeah, they give us that. What is the dose of chloroquine injection? Dose of chloroquine injection you will give to a child of 8 months. So they say age of child. Age of child is 8 months. Okay. When the adult dose of chloroquine, yeah, chloroquine is what? We have 5 mils. So once you see this, So what we're looking for is what? Pediatric dose of chloroquine. You should know that your answer will be in mils because the adult dose is in mils. But then once you get the mils, you can also get what? The milligram. So once we work this out, we don't need to apply the formula. Pediatric dose. We have 5 mils, right? Times 8, right? 8 over 150. 5 year 1, 5 year 30, 2 year 4, 2 year 15. I'm correct? Yes. So we have to divide what? 4 over 15 mils. What would that give us? 15 here is 0 points. We have 40. That is 2. 30. I think we have what? 26, I think? 26 mils. And approximately you give 0.3 mils. Because we will be able to give 0.26 mils. Although just rationalize that dose. Is that fine? Okay. Now let's go to the third calculation. Now, we want
Yes,
so classes say that we use the weight, we use the weight of child over 150. Weight of child must be in pounds. So class rule, and the fact is, I want to go over the calculation again, bit by bit, before anybody will say that they fail because they are divided into two. So we say weight in pounds over 150 times what? Adult dose over 1. So once we have this for class rule, what we have, so what is the dose of paracetamol you give to a child? So I have to calculate what pediatric dose of PCM for a child. Weight, pediatric weight is what? 20 pounds. When the adult dose of PCM equals to 1000 milligrams. So what do we do? Let's divide the board. So since our we don't need to divide it, so we can put it straight away. We are working in pounds now.
Yes,
so we can just have our, we slot it in 20 pounds times what? 1000 milligrams over 150. So we have this here, 5 year 3, 5 year 20. I think we have 20 now. There. So we have 400 milligrams over 3. That should be 133. Is that so? So 133.3 milligrams. So approximately the charge should be given 133 milligrams. Now with this formula, the weight of the child will be in pounds. If you are given, if we give you this, we can give you the weight in kilograms. You are going to take the weight from kilograms to pounds. And what's that conversion again? Kilograms to pounds. What's that? 1 kilogram equals what? 2.2 pounds. Or 450 grams equals to 1 pound. But let's use this. 1 kilogram equals what? 2.2 pounds. So this is what we do here with this one. So having done that, we look at the simple proportions here, the addition of everything. Now it's not going much because we did the class rule. So the other one is simple proportions. Let's look at D here. Calculation of drugs using simple proportion. Now, this one, we have example 1. 10 mils of procaine penicillin. This is a drug. Contains 4 million, right? Or 4 million IU, international units. So how many meals? How many meals of this drug will you give to a patient requiring 400,000 IU? That's all. So solution is simple. There's no formula there. You compare it. If 10 mils of procaine penicillin equals to what? 4 million international units, right? So we now have what? 400,000. So look at it. This is IU. My 400,000 will be on this side. 400,000 IU equals to Z. So at this point, you cannot do addition or subtraction. You can only multiply. You cross multiply. So on this side, we have what? Z times 4 million IU equals to what? 10 mils, right? Or PP times 400,000 IU. So we divide both sides by what?
4 million.
By 4 million. Yes, 4 million. So this goes here, this goes here, right? 4 cancel from 1 as Z equals to what? This one here, this one, we have what? Then we cancel this 10, right? So we have what? 1 mil of procaine penicillin. So I think that one is straightforward. So what we get is what? You will give the patient 1 mil of procaine penicillin. That's clear. Now let's look at dilution of lotion.
Sorry, sir.
Yeah.
I will
I want to look at dilution of lotion because this one gave us dilution of lotion. So here, the formula we have is what? We have required strength over what? Stock strength times what? Amount of what? Amount required in volume over 1. So, and I said the other day that what are we looking for? The other formulas we did, for some we were looking for what? Pediatric dosage. So with this formula, we must understand what am I actually looking for to use this formula. And if you read this introduction here, that there are times that you need to prepare a solution you need to prepare a weaker solution from a stronger solution. The stronger solution is the stock solution. What you are preparing now is a weaker solution that you can now use. Because if you are going to use acid, for example, now in second, you cannot use you cannot consider acid. You must dilute the acid, and because some students will drink the acid while they are trying to suck the base into the blood. They drink it, you feel so good. If you are the concentration of corrosive, the person can die. Because if it's dilute to a level, it can. So we're using this one, and I said that we are still looking for something here. Then if we look at the question, let's look at question 1 under this to shed more light to what we actually were looking for. We are told that what? 1:20 Savlon is available in the world. Control availability of Savlon is what? 1:20. Now, the nurse needs to make 300 ml of 1:60 Savlon. Required. What is required? Is what? 1:60. So 300 ml of 1:60. this one is available in the world as stock. The nurse needs to make 300 mils of 1:60. So the nurse cannot just go and take this one and pour water. We must determine with the formula what we are supposed to do. So we have this, we have this. What kind of information do we have there? So what does the nurse, she wants to make the sablon to clean a rubber catheter. That's the reason they gave us. The nurse said, what amount of the required strength we should take from the stock strength? So what amount of the required strength we should take from the stock strength to which water will be added in order to give the required amount? So what we're actually looking for is what? Amount of required
amount of stock strength.
Amount of stock strength, sorry. Thank you. Amount of stock strength in mils. This is what we're looking for. Because that's what we need. We need to find out what amount of the stock are we going to take to now add water, because we are trying to dilute the solution. So once we have this formula, we can go ahead with the working. So I'll put this into two space. So we are looking at amount of stock strength, or in some case can say volume of stock strength. This is what we are looking for. Amount or volume of stock strength. So we can use our VSS. So VSS equals to what? What is the required strength? 1:60 over what? Stock strength 1:20 times what? Amount required or volume that we're going to make 300 mils over 1. So what does this one? How do we interpret it? This is 1/60 divided by what? 1/20 times what? 300 mils over 1. So if we go ahead with this, we have VSS equals to 1/60 times 20 over 1. All of it together times 300. Please keep the list there. 120 here, 120 here, 3. So we have VSS equals to what? 300 mils over 3. So what we have is what? 100 mils. So what did we calculate? What can we also amount of stock strength needed, or the volume of stock strength needed to make 300 mils of what? The required. So everything we are going to make is what? Will be 300 mils. So it means that we will take 100 mils of what? Of stock.
Of stock strength.
Yes. Plus what? 200 mils of water. We add it together to get what? 300 mils of what? Required. Abi?
Yes.
Required solution of sablon. This makes what? 1:60. 60. This is what we are supposed to do. So you must understand what we are looking for. That we are looking for what? The amount of the stock strength we are going to take, which we now. So once we know the amount of stock strength we are going to take, the rest we are just adding water to make the volume they ask us to make. Do we get it? Well, that's what we need to determine. So
sorry, sir. Are you now saying that there will be?
It said make 2 pints. Make 2 pints of Lysol 1:80 solution from stock strength of 1:20. So this one too is simple. Solution VSS VSS, right, equals to what? Required strength, right,
Stock strength
over stock strength
multiplied by
times what?
required
Amount of,
volume.
Not
Required
stock.
volume.
amount of,
Or volume required.
or volume of what? Required solution over 1. So if you get this, you have what? 1 ratio 80 over 1 ratio 20 times what? 2 pints.
That's 2 pints will be. Okay. So we are not converting the 2 pints.
There may not be any. If there is at the end, we have 1 over 80 times what? 20 over 1 times 2 pints, right?
That's 2 over.
This is 4. This is 2 pints over 4. That's what? 0.5, I think? 0.5 pints. So you now find that one in your. So it means that what? We are not done yet. It means that what? We have to make 2 pints of Lysol 180. So what do we have?
That's
It means that what? It's 0.5 pints of what? Of stock
of stock plus 1.5.
plus what? 1.5
water or diluent.
pints of what?
Water.
Water.
Or diluent.
This is what you need to understand. This is what you need to understand. How much, what is the quantity of what? Stock. What is the quantity of what? Water. So let's do the third one there. I think we might have to do the third one. Make 3 pints Lysol solution 1:60 from a 3% solution. We have to make 3 pints of Lysol solution 1:60 from B. So what we have? We have our VSS equals to what? Required strength over stock strength times the amount of volume of required strength over 1. So here we have our required strength to be 1 ratio 60. Our strength to be what? 3%, right? That's 3 ratio 100 times amount is what? 3 pints over 1. So what do we have? 1/60 times what?
100
Divided by 3 over 100, right?
Yes.
Times 3 pints. So what do we have there?
That's
1/60 times 100 over 3 times 3 pints Lysol. So it's all comes to 0 here, right?
Yes.
So we have what? 10 over 18, 2 here 5, 2 here 3. So this is what? This will give us what? 5 over 9 times 3 pints. 3 here 1, 3 here 3. So what will 5 over 3 give us? 1 point what?
1.2 and
That's it. I want it in decimal. 5 over 3.
1.7.
Huh?
I think it
I need the correct figure.
should be
1.6 something.
1.67.
That's is it 1/2/3?
Yes, just 5 over 3. 5 over 3 is what? At times the part is even more beautiful than before.
1.66.
Don't worry.
Approximately 1.7.
7.
Approximately, I like that part. 1.67 pints of Lysol, like of the stock
Of the
solution,
stock. So now
right?
1.2.
So now add what?
1.2.
Plus what?
1.3.
1 point what? 1.33
1.33, yes. Of
plus
water.
1.33 pints of water to make our 3. Do we get it? So So this is, we're doing it again, and I don't think anybody else should
That
have.
should be 1.40, sir.
1.4 to 7, 10.
Yes.
Bring 1 here now, 7
Okay.
is 3. So we have these calculations in administration. Administration of what? Of intravenous infusions. So we do a lot of this, but we want to do one here. So we have that one as for calculating drops per minute, okay, of intravenous infusions. We use this formula. Formula is total volume of given fluid over time times 15 over 60, which is a constant here, according to this textbook. So we look at other variants of that formula later, but this is the formula we are asked to work with. You put the total volume of the given fluid over time times 15 over 60. So we have in seconds there. So we have example 1 here. We have calculate the number of drops per minute for 4 liters of normal saline to run for 8 hours. So this is what we have. So using this formula, total volume of given fluid is what? 4 liters. And 4 liters equals what? 4,000 mils. That is clear enough. Time is what? 8 hours. So we take hours to minute because it is the answer is in what? Drops per minute. So our time cannot be in hours when the answer should be drops per minute. So we have 8 here. So 15 here over 60. So I will explain why we have the constant there. 15 is a constant because of what? Because of the secondary set or the delivery set we're using. Yes. So this is what we call drop factor. The 15 here is drop factor. And drop factor can be what?
10,
either 10
15,
or 15 or 20. This 60 is here because we need to convert this time to from hours to minutes. So that's why we have that there. So ideally, the formula should what? Total volume in mils times drop factor over time in minutes. I hope you got that. So the formula should be total volume in mils. When you want to use total volume, mils or liter, times the drop factor over your time in minutes. So if we extract this, we have 4,000 mils over 8 times 15 over 60, 1 over 4, 4 here, 1,000, 4 here 2, 4 here, 250, 250. So what we have is 125 drops per minute or 125 GCT per minute.